Welcome and good afternoon. You probably just heard that we have things that are being recorded in progress. That's for your benefit. So at the end of this webinar, you'll be able to access a recording. So I just wanted to give everyone a heads up. So I just want to say welcome, a very warm welcome to this Halloween version of the 5 costly mistakes utilities make with FERC Order 2023. And today you're going to learn about the 5 costly mistakes that utilities are making with FERC Order 2023 right now. And the good news is this is not theoretical. We've got some boots on the ground examples for you today, and we are being joined by some folks in the field. So my name is Laura, and I'm the Director of Sales here at CartoVista, and I'm delighted to be joined by my team, Danny Bouchard. We can see Harry Barcia as well, and a special guest from PNM, Stephen, and I'll give him a proper intro a little bit later on, and he'll be sharing some of the lessons in the field, and we're very grateful to have him here today, along with all of you guys. So quick note, like I mentioned, we are recording that will be shared at the very end. We'll go through this. There'll be a Q&A at the very end. You can drop your questions throughout the entire presentation and down below. So we'll jump into what we will cover today and what you'll learn. So in the next 45 minutes, you'll discover how PNM approached FERC Order 2023. Stephen's going to talk about some of the process. You'll gain insights on blind spots that we often see, and we'll dive into the meat and potatoes of those things as well. And we'll wrap up with key takeaways and the Q&A as mentioned. Again, drop the questions down below and throughout the webinar, and we'll be sure to answer those at the very end. And the goal of this webinar at the end is to leave you walking away with a clear roadmap using lessons learned. We know that for the majority of you, you're either completed this project already or nearing the end for looking at 2026 deployment. Our hope is that we can give you things that will still be of value. And we're looking to make sure that you can save time, money, and build trust. And I'm going to hand this over to Danny to set things up.
Beautiful. Thank you, Laura. So let's start with a bit of context on how we got here. Back in 2018, MISO was the first utility to launch a public-facing heat map with POI analysis. That project really set the foundation of how utilities visualize interconnection capacity today. Since then, the order has driven the industry to make the interconnection process more open and accessible. CartoVista has collaborated with several utilities, including Southern Company and PNM, to help design and implement their own heat maps. Under the new order, these maps must be publicly available without a login 30 days after each cluster study or restudy, of course, while maintaining or remaining CEII compliant. It's an exciting evolution, moving from data buried in spreadsheet to interactive, transparent tools that empower both developers and utilities. And with that, Laura, this is the perfect timing to introduce our guest speaker.
Perfect. Thank you very much, Stephen. We're so grateful to have you here. Stephen Jenkins is the manager of transmission planning at PNM, and he has been the one that's been spearheading the FERC Order 2023 project. PNM's heat map application went live in March of this year, and he is here to share more about it. And I'm just going to hand it on over to him without further ado.
Great. Thank you, Laura, for the introduction. So just a little background information about PNM for those of you who aren't familiar with us. We're a small utility based out of Albuquerque, New Mexico. We have around 550,000 customers across the state with a peak load of around 2,100 megawatts and around 2,800 in the BA, which includes some other utilities. We have around 2,100 miles of 230 and 345 kV transmission and 1,200 miles of 115 kV transmission. And our service territory covers most of the state of New Mexico, with some notable exceptions down in the Permian Basin in the southeast of the state, Farmington in the far northwest of the state, and Doña Ana County in the south. All right, so getting into our Order 2023 process. So it was really big news to the industry back in November of 2023 when FERC issued the milestone Order 2023, named after the year it was issued. The regulation included sweeping reforms to interconnection study methodologies, the timelines for completing the studies, and incentive structures for the utilities. The order also increased the stakes for the developers who are proposing these projects, requiring more security, more project specifications up front, while improving transparency and access to information from the utility to the developer. And under the new paradigm, utilities are required to make that heat map that Danny was talking about available to developers that shows what a rough idea of what their estimated impact of their proposed projects would be on the grid. So why should we care about making a good heat map? Well, when the information is reliable, the developers are drawn to your system because of that increased transparency, and it builds confidence and momentum for your system. The quality heat maps, they lead to a stronger, better informed application from the developer, which would have fewer upgrades, faster construction timelines, smoother approvals from regulators, and just overall better quality. And reducing that uncertainty early helps fix expensive fixes later, saving money for both the utilities and the customers. A larger pool of quality applications boosts the load, drives the revenue, creates long-term value for shareholders. And overall, it's a positive feedback loop where good data leads to better projects, and better projects grow your grid, and the cycle continues. So PNM got started on this process right after the order was issued. And the first thing we did is we looked at what off-the-shelf products were already out there. So we began testing a bunch of different platforms, both calculation and visualization tools. And we started small. We used a 6-bus test system where the data was really easy to synthesize and understand. And this helped define clear requirements before moving forward with any of the vendors that we looked at. And with those requirements in hand, we launched a formal RFP. And the selection focused on the user experience, the technical capabilities of the tools, as well as the cost in order to find the right partner. And so over about 6 months with the CartoVista team, we worked closely, holding JAD sessions, testing out features, finalizing the documentation, and doing training before we had our launch in March or April of 2025. And this structured approach from trials to RFP to implementation ensured alignment, minimized risk, and set a solid foundation for a successful rollout. So our first map that we made available was for our cluster 14. PNM's been on a cluster study process since 2011, and so we had already had some familiarity with doing cluster studies. And it wasn't just a visualization project, but it was a lot of work behind the scenes on the data and the analysis. So we worked on the full cluster 14 data set, which had 17 million records and 8 distinct scenarios that represent different dispatch conditions in different regions of our system. And this allowed the map to reflect the real system behavior, and it's not just a simplified snapshot. And CartoVista, they did a lot of customization for us, which was very valuable in creating the best product that aligned with our vision for our customers. We really appreciate the high quality branding and design. It's unparalleled from the other vendors. A key feature that they built for us was the transmission line constraints view. And this is something that's on the back end. It's not on the public map at this time, but it allows for a straight line approximation of transmission lines connecting substations, or even the actual routing of the line pulled from public data sets like OpenInformap. And that really shows you how the substations are connected together, because just because you're geographically close between two substations doesn't mean that you're electrically close. And so when a new injection is added in this POI analysis module, the map automatically zooms to the section of the map with the constraints. The heavily loaded lines are drawn in bold. And when you select the overloaded line, it highlights the contingencies that cause the overload. And this is huge for understanding where and why congestion is occurring and determining the best mitigation for the overload. And with that, I'll hand it over to Danny.
Thank you, Stephen. So for us at CartoVista, this was also a major achievement for the POI analysis module that Stephen just mentioned. We introduced a new configuration wizard, giving engineers and planners the ability to define study parameters without writing code. On top of that, we added transmission line constraints, helping users visualize where grid limitations occur. And if we keep, of course, with our Halloween theme going, you could say that we turned a pretty frightening amount of data into something that's not scary at all to explore. Now that we've uncovered the highlights, let's lift the curtain and discover what was special and what is special about the PNM map. So we view this as a real milestone with several new features that really made the experience far better than our previous heat maps. First of all, we have the worst cluster analysis, which lets you compare current post-project and worst dispatch in one view. We also have the current generation layer overlay, which really adds context by showing you where existing generation already sits. We also have POI analysis results that are now including clear definition and tooltips for terms like DFACS or FCITC. We also have enhanced map labels. So all of these things, make the map clear. They, are easier to use and, provide a better experience. So let's jump into a quick demo to see it all in action. So let's take a real example. So let's imagine that I am a solar developer exploring where to connect my project. So as you can see here in this short clip, there are disclaimers and onboarding, but I will just skip that and go straight to the map. So the color gradients that you see represent the available interconnection capacity under those specific conditions that are selected. Blue and green areas indicate higher available headrooms, region that can likely accommodate new generation. Yellow to red show where the grid is more constrained, and adding new generation could cause overloads or require upgrades. By default, the map opens in the high renewable central scenario. But because our project is located in the northwest part of PNM system, I'll switch to the high renewables northwest scenario to reflect the grid conditions and renewable output in that region. So as we start zooming into the area, you'll discover in a second that we can see a few blue pockets on the map, showing that there's still some available capacity. Now for our project, we'll focus on the 115 kV level. And when I pick that voltage, the map actually updates to display capacity specific to that level. Before testing where a new project could connect, it's useful to understand what's already on the grid. Turning on the existing generation layer, we see the current mix of power plants across the region. Each icon represents a real facility, coal, gas, solar, or battery, and rolling over them reveals details, including from the legend. We can see in the center area around that Jicaria substation, we can see existing solar and battery sites. All right, next, we're going to turn on the current queue to see what's already in line for connection. And we can see near that substation in the center right there, it's all solar and battery project, which means that most of the available capacity in this area is likely already taken. Now, let's test our solar project at that bus specifically. All I need to do is to put in 60 megawatt and hit enter. And as you'll discover in a second, the analysis returns red, in this case, indicating overloads. So the system really can't support the injection at that location without upgrades. I can expand that table and show all constraints. Of course, there could be multiple, like in this case. In order to explain the data better, the column definitions at the top are displayed for the end user, on rollover, making it easier. You can also easily copy the data to your clipboard or generated a branded Excel report with all the details and definitions. Our users actually love this feature. It saves time and really looks professional. Now let's take a closer look back at the map. We have an option called the post-project toggle, which is showing you the capacity decreasing after we injected our 60 megawatt project, like a before and after state. You can see the color changing. I can even switch to a worse dispatch view to see how the grid performs under less favorable conditions. And of course, in this case, the map turns a lot more red. Now let's clear the results and try another substation at that location and see if it works. As you can see, we're still red. The project doesn't work there, but let's try another in that blue area right there on the left. And we can see that this one passes cleanly, no overloads in this case, confirming that this area to the west has more available transmission headroom. So in just a few clicks, we've narrowed our options and identified a viable interconnection point. This is how easy it is for developers to spot opportunities, assess grid constraints, and find the best place for their project. All right, Laura, let's let you talk about the concept of an implementation.
Awesome, thank you. So Stephen kind of kindly set this up in a sense where he was speaking about different aspects of the implementation journey. And with the electric utilities that we work with, this is a very similar journey. So you can see the front end and the back end and the experience are all part of this. But the reason this is relevant is that, success depends ultimately on how well all of these stages work together. And we can see that there's many moving parts between data, integrations, UX. We've got security, of course, approvals, and failures. What we found often happen between handoff points. And so we will dig into what those look like. And I'm going to pass it back over to Danny to get into mistake number 1.
All right. So one of the common mistakes we see is that utilities really approach FERC Order as a data export problem rather than a user experience problem. So this is understandable because the first instinct is usually we have the data, we just need to expose it. So too often utilities, they just think about this as a data release, upload a file, publish a map, check the box. But in reality, these maps are used by real people making complex, high-stake decisions. Developers aren't just downloading numbers, as we've seen in the demo, they're exploring and testing scenarios. And if the experience isn't intuitive, they give up, draw the wrong conclusions, or worse, flood your team with clarification requests. So the real challenge isn't just getting the data right, it's designing the experience around how people use that data. And that's exactly how our first tip focuses on. So tip number 1, no surprise, is to focus on the end user. This isn't just a tool for engineers, it's a public-facing application that will be used by a wide range of people, developers submitting projects, consultants, or even community members trying to understand capacity. You have to assume that your users aren't technical. They shouldn't need to understand megawatt rating defects to get value from the map. Good design removes friction. The user should feel guided, not overwhelmed. When you put the user at the center, compliance becomes more than a data requirement. It becomes a communication tool that builds trust and transparency. Tip number 2 is about the process. One of the challenges in designing a FERC-compliant map is that we rarely know what the user exact process is. Some developers come in with a blank slate. They're just exploring areas where they might connect. Others already have a parcel or even a substation in mind. We also don't know how large their project is, what voltage they're going to need, or even if they plan, when they plan to apply. So that's why the interface must be flexible enough to accommodate all of these things. Tip number 3 expands on the importance of clarity. One of the most common pitfalls we see is that when data is simply pushed to the map without thinking about how it's visualized. When everything is displayed at once, every possible POI, the map can become overwhelming. User can't actually see what matters. In the example here at the top left, the generation capacity is hidden because of overlapping points. There could be some capability there, but the end user really doesn't know. A better heat map like the one on the right helps people explore and see what's available. And beyond the visualization itself, clarity also comes from communication, a branded, guided experience that helps the user trust what they're seeing. Simple things like onboarding messages, disclaimer, or even a short tour makes a big difference. In short, clarity builds confidence. Moving on to the scary mistake number 2 now with Laura.
Awesome, thank you. So mistake number 2 is about building in a bubble, and it's really about staggering teams correctly. And we'll jump into some details about that. So even great teams make this mistake. So moving fast, we all know that compliance is king, of course, but if you do bring in legal or security or communications at the very end, there can be some issues. And it's not that the work is wrong. Of course, that you can do things technically correct, but the timing is really the issue here. So when key people aren't part of the plan early, what should just be a quick approval ends up turning into things backtracking and deadline slipping. So let's take a look at how to create team alignment from the very beginning. Give you some practical tips. So in a heat map project, success depends on everyone moving together. So this includes the transmission planning team, GIS, IT, communications, as well as vendors. And for context, we know that the transmission planning team provides the core data and the GIS team ensures spatial accuracy. They can be involved in things like data validation and things. And IT manages integration and security. And the communications gives a go-ahead for things like branding and the green light for the map to go live. And vendors can really help accelerate that delivery, but especially if they're part of the process. And when teams align from the very start, we can avoid rework later. And so that's going to lead us into our first tip here. Yes. So one way that we've actually heard Stephen talk about this earlier when he was mentioning JAD sessions. One way that we've seen utilities get aligned is through joint application development sessions, also known as JAD sessions. And these are just quick focused workshops that are designed to move fast while keeping everyone in sync. And it's the idea that we want to make sure that there's no scope creep or anything around timelines. Everybody is on the same page at the same time. So you'll see here on the left in the orange for JAD session number 1 is where we focus on discovery. So we review the data, we look at IT needs, we make sure that branding and functional requirements are all aligned. And next, we look at things visually. So we prototype, we do wireframing, we validate and make sure that everyone is on the same page visually and get sign off on that to make sure that the results are all what we're expecting. And finally, we take a look at the specs, and we get sign off, and then we move forward. So that's basically what we do with JAD. And I think the question that everyone's probably asking is, okay, so that's great. Now what goes into all of that? I'm going to hand it over to Harry to talk about the data and how all of that works. Over to you.
Laura. So we call that mistake assuming the data is 90% ready. It's a mistake that every utility has felt at some point when it comes to data. It looks ready until you start connecting it all together, and that's where the real surprises show up. So first, the cluster studies involve a lot of data, millions of records. You got POI data, transfer studies, millions of records across multiple tools like PowerGen, GIS systems, and that's where the real challenge begins. On paper, it looks ready, but once you start leaking everything, bus numbers, coordinates, midpoints, your scenarios, KV levels, that's when small inconsistencies can turn into big delays. Our first tip is simple but critical. You must start validation early. Too often, teams assume their data is ready, only to find problems after the integration begins. And that's when hidden issues surface. Things like missing or mismatched POIs, inconsistent naming, duplicated or overlapping coordinates, buses that don't match with transfer study data. And finally, also the validation loops that take weeks because multiple teams need to manually confirm before anything can move forward. So the data itself isn't bad, it's just being tested too late when fixes are harder and timelines are tight. Validating early helps you catch those issues when they're still easy and cheap to fix. So our second tip is very much linked to the first one, is to leverage GIS and third-party datasets to help with validation. By third-party dataset, we talk about public data like OpenStreetMap, but also public data from electricity, public, government type of data sets. And GIS isn't just for visualization, it's a powerful tool for catching mistakes before they spread. So in the screenshot, you can see at the red point is a POI that was misplaced on the map. For some reason, it was offset by a few miles. And what we did was to autocorrect by cross-checking with those data sets, with OpenStreetMap, for example, and correct it on the right place where the green points are. So you can really cross-check your POIs and flag things that don't line up. On top of that, there is coordinates that fall outside expected areas, duplicate or misplaced substations, or lines that don't match real-world geography. You can even build auto-correction rules, so these fixes happen proactively, not at the end of the project when everything is already live. So the key idea is let your JS and ETL tools do some of the validation work for you. So Laura, over to you for mistake number 4.
Thank you kindly. So mistake number 4 is skipping IT integration from the beginning. And especially after the system is built, I know that some of you are building internally and some of you are using external. This goes for everybody. So we'll take a look at what that looks like. If IT is brought in too late, unfortunately, there's problems that could possibly pop up instead of integrating properly. So some of the things that we've seen happen, if IT is brought in too late, is security gaps. Sometimes we're looking at manual workflows. I know that, I think it was Danny that mentioned that every 30 days after every cluster study or restudy, this data needs to be updated. So this is important. There can be incompatible data formats, deployment blockers, and things like that. And so we're trying to avoid delays. And so the idea is to make sure that before the main structure is actually built, that IT is part of all of this so that we can focus more on integrating. And so some of the things to focus on early, security, automation, or SSO must be not only brought in early and done early, but planned early. So we'll take a few look at a few tips on how to actually tackle this. So tip number 1 is to define your deployment model. So when it comes to IT, there are 2 main things that really make the difference, and it's deployment and security. And we're going to touch on both of those here. Both ultimately need to be defined early. And for deployment, the first question is ultimately, once you guys meet with your team and figure out what the needs are, what are your choices? So the choices are often, should we go in the cloud or should we enroll on-prem? And you can see the box on the left here. The cloud is usually less expensive. Some of the benefits, it's easier to maintain, it's faster to update, and it's perfect for utilities that want quick and reliable access with fewer, operational hiccups. We've often found that the utilities that we've worked with have opted for this option for the FERC Order 2023 application in the way that this is public-facing data, so it seems to be the choice for most. And then on the right, you can see on-premise or private cloud. And the benefit is that it certainly offers more control and flexibility, and it does come with a bit more complexity and higher costs as well. And when we talk about security, it should not be an afterthought, of course. So some of the things to think about with this security is thinking about single sign-on or SSO, as well as multi-factor authentication early. And ideally, you can look at tools like Microsoft Entra ID, and so that just makes it simple and secure for users to access. So to sum it all up, it's about balance, to make sure that you're planning your path, making sure that you're simplifying security and avoiding the nightmares that could come down the pipe with IT if not. So next, we're taking a look at integration. Of course, this is where everything comes together or falls apart. So we are going to kind of take this apart a little bit. So when you're building your heat map or your POI analysis system, ideally, you're going to want to work with open formats. So things like CSV, shapefiles, Excel, or JSON, so that you can easily exchange data with other teams and tools. And one of the other reasons why this is important is that it can stay compatible with your transfer analysis software. So you could be using PowerGem, PowerWorld, PSSE. It doesn't really matter as long as you're using open formats. And that way data can flow smoothly without extra conversion steps. And one of the utilities that we were working with actually decided to change up their transfer analysis software midway through the project. And fortunately, that was really easy for us because they opted to use open formats. Certainly made their life easier, our life easier, and it's just a good tip whichever way you go. Designing with open standards, it basically helps you future-proof things as well with your integration, and that can help with avoiding scary surprises. And the last piece of the IT backbone is automation. I briefly talked on that earlier when it comes to updating data. It's certainly one of the biggest time savers, and you can build it from the start. So your engineering team and vendors should be able to connect directly through APIs so that the data updates don't depend on manual imports or spreadsheets. And you can certainly leverage tools like Python. You can create a script to help automate data refreshes, validations, and even reporting, actually. And that can keep everything synchronized without extra effort anyway. And the goal is to design ultimately a system that runs smoothly on its own, where update checks and integrations happen automatically, and you don't have to do that manually. So the goal is to keep everything alive and good on the IT side. So we're coming around the bend for mistake number 5. I just want to remind you, if you have questions, you can drop them down below. This mistake number 5 is probably one of the most expensive, and it's the easiest to bury. And I might call on Stephen here for a second. I'd like him to chat about Section 403 that was recently announced. The whole idea here is that many compliance teams are really rushing to just meet compliance for Order 2023, and it's really understandable. But what we solve for 2023 can easily become a thing that's a problem in the future. And so I'm just going to pass the buck over to Stephen to speak about the new update that we've heard about.
Yeah, it's still pretty early, but there's been a lot of interest in implementing a FERC Order 2023 type process for large loads. So last Friday, FERC issued, the DOE issued to FERC a directive to look into doing something like that. And what's really cool about this heat map product and the customizations that are available is that it'd be pretty easy to flip the sign. Instead of doing an injection, you put in a load, and changing a couple of different terminologies on the interface. So it's like add a large load here instead. And it'd be pretty easy to spin something up for large load prospecting. And I'm pretty sure everyone in the country is dealing with, especially data center loads coming and trying to find a location that they can get online and quickly. And then whatever we can do to introduce them to the generators that are in the queue in order to get their large load online and get the resources that they need online, and do it with the minimum amount of upgrades and cost to the data center and the utilities customers. So
Thank you, Stephen. Yeah, I think that was really well said. And that it was funny yesterday, Stephen kind of had mentioned that this has come down the pipe. And what's great is that we've already started thinking about this before PNM was working on their project. We had thought about these things coming down the pipe. So when it comes to designing for only FERC Order 2023 compliance, you can see that there can be some stopgaps that we only just found out about recently. So there are a few other things that are changing as well. It's, their users have certain expectations that are relevant. So they're requiring more modern interactive experiences as well. The speed and response time is important. They don't want just something that is static and hard to understand. It needs to feel intuitive and fast and fluid. And of course, performance matters too. We know that we're working with millions of records, and as Stephen mentioned, we're exploring these large load. All of this is going to become, more significant when it comes to performance, and so the ability to process millions of records very quickly is important. And of course, we know that AI is raising the bar even higher, and users expect insights, not just visuals. They need to help understand and derive this and make decisions using these types of tools. So it's not just about meeting compliance, it's beyond that. So we'll jump into tip 1, designing for change. FERC rules will change, of course, and that's okay. The goal is really not to predict every new requirement. It's to build a foundation that you can use and build on. Your architecture should adapt to new data sets, new rules, new workflows without needing to rewrite. And tip 2 is keeping it modular. So if you imagine working with Lego blocks, every piece should fit together cleanly. So if you need to change something in a layer, or if you need to edit some parts of the data, it's about reconfiguring, and you don't have to pull everything apart, and it's not going to cost you a lot of time to be able to solve. And number 3 is plan for scale. More data is coming down the pipe, more users, it's going to get more complex, it's all coming. And so the smartest teams are automating to help kind of bridge that gap, and different update versions can happen pretty quickly. So the best systems are built to evolve, as we know, and they're not just to meet compliance. And so that was a lot, I'm sure, and we're going to do a really brief recap. Again, I'm just going to remind you that if you have any questions, you can drop them in the chat. And we're going to do this recap focused on PNM project and what we've heard Stephen say, just for some key lessons and how you might be able to apply those where you're at. So the first is that PNM avoided the data export trap. We know that many utilities start by thinking for compliance is just about publishing data or compliance is king, but PNM took a different path. So we saw that they designed an experience. Their heat map lets developers explore interconnection capacity visually. They can understand constraints and compare worst case scenarios in that one place. We also looked at collaboration over silos, and we saw that the project success came from how early they aligned. We heard Stephen talk about those JAD sessions where they brought in all members of the team very early, and it did mean fewer surprises, and they avoided kind of building in a bubble, and that trap really was avoided, and they were able to go quickly. And number 3, validation and integration first. We saw that for PNM, they have millions of records across 8 scenarios. They looked at data quality, and that could have been really difficult, but they didn't assume that it was 90% ready. They focused really early on validation, security, automation, API connections, and they made sure that all those things were part of the architecture from day one. And last but not least, we looked at future-ready design, and PNM didn't just build for FERC Order 2023, they built for what's coming next. And that software design, mentality allowed them to integrate different data layers, create different visual updates, and allow to accommodate evolving FERC rules without significant work. So ultimately, to wrap everything up, if there's one main takeaway from PNM, it's that compliance was actually just a starting point. It wasn't the finish line. And so the utilities that will thrive, we believe, in this FERC era are the ones that are building systems that evolve. And I will say that we're very proud to be helping utilities and teams like this lead that transformation. All right, everyone. So again, if you haven't already, it's time to ask whatever burning questions that you may have. I am going to kick things off.
I think I may have a question for Stephen. Why not?
Okay.
We have him, and we should take advantage of that. So Stephen, maybe over to you. As FERC expand transparency requirements, including the new plans related to load that we just talked about, what do you see as the most important consideration for utilities moving forward? What's important in your mind?
I think that the transparency is very helpful for all of the customers, not just the large generator customers or the large load customers, but even the general public can get out there. They can see where substations are located at. They can see how the grid is built. I think it was in Order 2023 that FERC mentioned that the CEII argument about not sharing this data doesn't apply because all this stuff is already publicly out there. You can go to openinformap.org and you can see where all the substations and transmission lines today are. And, you know, it can be difficult to convince people who have been in the industry for a long time that this stuff isn't like trade secret or anything, and the public needs to be involved, and including them more makes more trust and builds a better system.
Absolutely. I think you're right over there. I fully agree. All right. I think we have one question that's coming from the audience. And maybe you can take this one. That's an easy one for you, Laura. So the question goes like this: how long does it typically take to deploy a FERC-compliant map with CartoVista?
Absolutely. That's a really good question. Of course, all good questions end with the answer, it depends, but typically we're looking at a 3 to 4 month window. It can be quicker if your data is up to date, if it's validated. It depends, but 3 months is probably safe to say. Again, if your GIS data is clean, accurate, up to date, we've come across utilities who also wanted things like they wanted a midpoint put in between their lines, but they didn't have the data. So of course, that's going to take a little bit of extra time and effort, but I'd comfortably within the 3 month window if you've got things up to date.
Yeah. Maybe an example, we've done work recently with another utility, and you can watch their heat map is going actually live probably next week. And I'm not going to mention their name, but we've done the work essentially in almost less than a month and a half. So their data was pretty much ready, and we did it very quickly. And we can't wait to release that third or fourth heat map out there to the public. That's great. We have another question from the audience, and maybe you can take this one as well, Laura. We don't have GIS resources within transmission planning. Can your team help us with our data before it goes live?
Absolutely. I think that's one of the things that we really love to do is that our GIS team kind of specializes in this. We do have access to lots of data. We also have access to really skilled experts that will take things off your plate. I know that some of the GIS teams are kind of, backlogged or just don't have what they need. So of course, we're able to help you out with that as well.
Great. We have another question, I guess, regarding the data hosting. So where is the CartoVista data hosted? You can take that one too. Why not?
Yes, we do have our hosting for AWS in the East in the United States. So it's it's hosted there. I do believe, do we have hosting in the West?
We do.
We
As
do.
a possibility, yeah.
East and West. Well, everything's a possibility for sure. So yeah, it's flexible, it's open, and we've had really positive feedback from folks so far on this.
Yeah.
So Danny, I just want to say it's 2:45. I think that we're good. Is there any other final questions that anyone needs to ask before we jump to wrap up?
I think we answered most of them. Yes.
Okay, wonderful. Well, just a couple of housekeeping things here at the end, everyone. I just want to say a big thank you, mostly to Stephen and the team here at CartoVista. Thank you very much for sharing your time and your insights. Stephen, your time was wonderful. It was great to have you. You will all receive a copy. I did see a question that came up about the recording for today's presentation. You will get that as well as the deck, and there will be a quick survey as well. You'll probably see that there is a QR code on the screen. If you'd like to join our Slack community, that's a great place to kind of have questions answered. There are other utilities that are there. We can learn about trainings, features, upcoming other webinars and things like that. And something else that could be of interest, whether or not you're kind of building something on your own or totally independent of whichever way you go, we're offering a readiness assessment. So it's a 30-minute sit down. We'll take a look at the plan that you have in place if you'd like. We can give our professional opinion about if there is any gaps and some advice that could be valuable to you. Our contact information will be dropped down below, and it will be available in the email that you'll get the recording at. So if you're looking to stay in the loop with all those things, again, you can scan the QR code and you will be getting an email with the recording for your pleasure. And so I just want to say again, thank you guys so much. Happy Halloween. Please be safe, and look for our next webinar coming up. That's going to be more focusing on the developer side and how everything comes together. So thank you very much.
Thank you, Laura. Bye-bye.
Bye.
Thank you.